Hello students, welcome back. In our last video, we completed the core mechanic of our game. We now have radioactive cells that we can spawn all over our battlefield. We have player collisions that we can use to push those cells, and we also have collisions between our cells and our goals, so we can earn points. We can contain the radioactive threat. What we're going to do now is create something known as a resource system, something that a player has to manage and keep track of. In our case, it's going to be something known as containment. As our cells become unstable and erupt and leave radioactive waste all over our battlefield, the containment level is going to decrease. It's going to drop. As we score goals, we could maybe potentially earn some containment back. If our containment gets too low, that's going to signal a game over. When we run out of containment, we have not been able to contain our radioactive waste, we are dead. Time to trigger the game over event. So let's implement our resource system of containment here in this video. So right now I have in vscode.dev, I have lesson 4, our starter file open on our reactor containment. I'm also going to go directly to where, let me close that whiteboard out. I'm going to go directly to where this file lives. So I'm going to open up my Corefall folder, lesson number 4. We'll open lesson 4.starter in the browser directly. And so if we look here, you can see I've got room in my HUD for containment of some kind. Okay, so that sort of works-ish. Good, I guess. And everything else just sort of looks the same, right? I can collide with the cells, I can score them, they spawn. Okay, so we got to implement this containment system somehow. So let's head over to the lesson and let's look at our mission checklist. Mission number 1, it says we have to add the containment constants. All right, so we're going to put some new constants in the game here. So I'm just going to scroll down. So here's our gameplay constants, right? This is in our student edit zone. We're going to look at what we have available to us for this new resource system of containment. And it looks like I have 3 new constant variables, and they are all currently set to 0. I don't think that's the right value. So let's set or tweak the parameters here to suit our needs. So max containment. This is going to be, what is our starting amount? What is, when everything is good, how much containment are we going to have? Well, I'm going to set that to 100. I think that's a good number. And then we'll slowly decrease this, right? We'll decrease it. And when this containment gets to 0, it's game over. And how are we going to decrease it? Well, if you look here, we have a constant variable called containment damage per explosion. Every time one of our radioactive cells explodes, we are going to lose some of our containment value. How much are we going to lose? I'm going to set it to 20. We'll lose 20 points of our containment. And then how do we get it back? Well, anytime we do a good job, right? We say, hey, we're not going to let this cell explode. We're going to contain it. We should get some containment back on that collision. And so right here, I have a variable called containment restore per save. I'm going to give us back 8. And like I said, these are values in the student edit zone. You can change these. You could take more away, take less away, give yourself more back, and it will tweak how the game feels and plays. Mission number 1, looking at our containment constants, is done. Nice job. So let's open up our search bar, Command F, Control F, and let's type in mission 2. Let's see what we have to do. All right, mission number 2 says we should reset the containment. Reset containment at the start of the game. So when we start the game, okay, whether it's a brand new game or we've died and we want to play again, we know we're going to call reset game to defaults. We reposition our player. We empty out our cells array. So any cells that were on the battlefield are gone. We set our score back to 0. Cells contain a 0. We spawn some new cells, and now we need to reset the containment system. So some of those variables that I just created, we got to talk about, what do we need to reset? Well, those variables we just created were our constant variables that tweak gameplay. But if I just scroll up, we also have some gameplay variables, things that will be used to control our game, right? Like our player object, our goals, our current game mode. And look at this. We have a variable called containment. See, we're keeping track of, where was it? Our maximum containment. We don't ever want to change that. We want to know what is our highest containment we could have. But we also need to keep track of what the actual containment value is. See, the maximum containment will never change. It's a const. But the current value of our containment will change. So we define it with let. And when we define it, we declare it as 0. But when we reset our game, we don't want to start our game with 0 containment. That would be extremely bad. So we're going to come down here into mission number 2, and we're going to say, hey, let's take that containment variable. Hey, look at that. I start typing. It's right here. I'm going to hit tab to autocomplete it, and I'm going to set it to max containment. So when we start the game, our containment system is full. Mission number 2, complete. All right. Our constants are defined. Our gameplay variables are defined. We have defined our data. So what's next? Well, we could update the data or we could draw the data. It looks like mission number 3 is asking us to start drawing some of our data. And so if we look here, we are in a function called draw containment bar. Ooh, and right above it, it looks like I'm calling that function. So I'm calling this inside of, draw HUD. Okay, so that makes sense. Because if you look here in my HUD, I have this containment text, and I probably need some bar here that's going to be filled in when it's at 100%, and then it will slowly drain down as we lose our containment. So in draw HUD, we're writing our title, all right, our movement, we're writing our score, and now we're drawing our containment bar. So if we look here, I defined a bunch of variables just for positioning, like the width of our bar, the height of our bar, the X of our bar, and the Y of our bar. So that's like the top left corner of our bar. And then I put some text in here. But so now what I want to do is mission number 3 is asking us to draw the bar's background, create a visible area for our meter. Okay, well, the first thing I think I want to do is put a good color in my paint bucket. So right now it's text color, which is that white. I'm going to put in a different color. So I'm going to do fill, and then I need some color. I don't know what color I want to use. Let's go look at our color palettes. So if I jump up here, where are our color palettes? Down a little bit. All right, so let's look at what we got for our containment bar. Ooh, look at this. We got containment bar BG color, a background color. And let's look at what it is. It's an RGB alpha string. So that means it's going to have some transparency to it. It's 255 in the red, 255 in the green, 255 in the blue. That means all the red, all the green, all the blue. That is white. But the transparency is 0.18. That means it is super duper see-through. In fact, if it were 0, it would be entirely transparent. So it's just going to be slightly, we'll just slightly see it. So that's going to be the background of our bar. And then we have a containment bar fill color, which if we look here, 4CFFB2, FF is all the green, B2 is a lot of blue. So this is going to be a lot of green and a lot of blue with just a little bit of red. That's probably going to be like some cyan color, I'm thinking. So let's use the background color for the paint bucket when we draw the background of our bar, mission number 3. So fill, what do we want to fill in here? I'm going to do containment bar BG color. Tab autocomplete is a wonderful thing. Now that I have the right paint in my paint bucket, let's just make sure. Yeah, I think this is good. So now let's actually draw our rectangle. So we're going to draw a rectangle. I need the top left corner of the rectangle. It's X and Y values. Those X and Y values I've defined right here for us for our layout. Bar X and bar Y. So I'm going to put those in. So bar X. Ooh, make sure you put the right capitalization on your variables, bar X and bar Y. And then I need the width of the rectangle and the height of the rectangle. My width is right here. My height is right here. So I like that. Bar width and bar height. Bar width and bar height. And then I'm going to round my corners. I'm going to put some rounding. So I'm going to put a 6 in here to round the corners. If we look, ooh, look at that. There is my HUD bar. So this is what it would look like if I were completely out of containment. What I now want to do is I want to draw a rectangle that fills in some of this gap based on how much containment I have. In fact, if you look just below, I don't even have to use the search bar here. Mission number 4 is all about the bar fill. We're going to draw the containment bar fill and scale the width based on the current containment. That's where it's going to get challenging. It's going to get a little tricky, but we can do it. I believe in us. So I'm going to put some paint in the paint bucket. So fill, and then I'm going to load in the color that we had just previously looked at. Containment bar fill color. All right, and let's just draw another rectangle. I'm going to say we'll start it at the same position. So bar X and bar Y. So the top left corner is going to be the same. And let's make the width, the height, and the rounding all the same. So I'm going to do bar width, bar height, and 6. Let's see what this looks like. Hey, look at that. My containment is completely full. Now, if I change bar width to 0, this would be completely empty. So let's see. All right, so there's completely empty. And I don't know if I did bar width divided by 2, what's that going to be? That's going to be like at like 50% containment. All right, so that looks really cool. But the thing is, we don't want to be like changing this value every time. We want it to dynamically change. So how are we going to do this? Well, when it's full, I'm going to put some notes down here. When it's full, our containment variable, containment, remember we had that variable that was called containment, it's going to equal our max containment. All right, and when it's empty, containment is going to equal 0. All right, and so if we think about this, I can turn this relationship sort of into like a ratio. If I do containment divided by max containment, when this is the case, right, if they're equal to each other, I should spell containment, right? Let me just do let me just fix that. Oh, I made it worse. Sometimes that happens. Containment. I spelled it wrong over here. Containment. There we go. Containment. Sorry for that. Containment. Oh, at this point, I'm just going to give up. All right, so if those two things are equal, when you have two equal values dividing each other, that ratio is equal to 1. Awesome. And then over here, if we do containment divided by max containment, if containment is equal to 0, 0 divided by our max containment is equal to 0. And so essentially, we get a ratio that is somewhere between 1 and 0. And if it were like 50%, guess what that's going to be equal, right? If it were at like 50%, then this whole fraction would equal 0.5. So we're going to use that ratio right in here. We're going to say, okay, let's do containment divided by max containment. I'm going to get rid of all of those terribly misspelled words. And let's check and see what this gives us now. Right now, containment is set to max containment. So max containment divided by max containment, this should be 1. Oh, and would you look at that? The width of the bar is 1 little pixel wide. That's not exactly what we want, because this ratio represents a percentage of the bar's overall width that we want to fill in. So we're going to take that ratio, which is a percentage of the overall bar's width, and we will multiply it by the bar's width. So when this is equal to 1, we're getting 1 times the bar width. It's the entire bar width. Zoop, right there. Hey, that looks really great. And as this changes, let's go find that containment variable right here under gameplay where is it? It was under reset game to defaults. Under reset games to defaults, we had it set to max containment. Let's set it to like, I don't know, 40. So now if we set it to 40, it's going to scale appropriately. Look at that. I'm going to set it to 10. It should scale appropriately. Look at that. I'm going to set it to 0. It should scale appropriately. It did not. I wonder why that is not working. Oh, there we go. Now it did. There we go. Now it's set to 0. It's just a refresh of the page. All right, so that system is working wonderfully. Let's set that back, though. We're going to be nice when we start our game. Let's give the user the maximum containment. Mission 1, 2, 3, and 4 now done. Very, very good. Let's look and see what mission 5 has in store for us. It says add a hotkey to simulate containment damage. Because right now, our cells are not exploding, right? The cell is stable. We got to make it unstable. We'll have a whole system in place soon to do that. But for right now, let's fake a system. We're going to add a debug hotkey for testing a cell explosion. It says add a hotkey to simulate containment damage. Trigger loss events to test this system. Because we want to make sure this containment system is working. So when a cell explodes, we take damage. If you look, this is inside of the key pressed function, which is going to check every time a key is pressed down, it can trigger something. So right now we're asking a question. It says if false. Well, that's never going to answer yes. So we got to ask a specific question. And based on the answer to this question, if the answer is yes, we're asking another question. That question reads, is the current game mode play? And is the length of our array cells greater than 0? Meaning, are there any cells in the array? If there are, we're going to delete one of the cells. Okay, we're going to delete the first cell for right now. And then it looks like we got to take some damage maybe. But that looks like there's a mission involved here. So the first thing we got to do is we got to figure out what key do we want to use to trigger a cell explosion. I'm going to pick X as my hotkey to explode a cell. So I'm going to ask a question. If the key that is pressed, if key is equal to 3 equal signs, lowercase x, or key is equal to capital X, in case you got that caps lock clicked on, we are going to splice one of our cells. We're going to remove it. Then we are going to try to take some damage. I don't know if the damage system is in place yet, but let's see if we can remove a cell. All right, ready? So I'm going to move around. I can score a cell, so that works great. And now let's explode a cell, hotkey X. And you can see that cell was moved. Now this is the first cell in the array. This should be the first cell. This is the one I should move. Oh, and I'm somehow up here. There we go. And I moved it. And I can keep removing and then spawning new cells. So that looks really great. Mission number 6, though, as I explode a cell, I'm not taking any damage. So that's kind of lame here. So we got to fix that. So mission number 6 says reduce the containment when a failure occurs. If you look right now, are we reducing containment? No, we're subtracting 0. That's not good. We want to lower that value when instability happens. So we're going to say, let's do containment minus equals. How much are we going to subtract by? I don't know, 3, 30, 300? That's not 300. There's 300. We actually have a value that we had set. Remember one of our constants? It was called containment damage per explosion. So we'll subtract that. Let's run this now. Let's see if every time we hit the hotkey, do we lose some containment? I think we were supposed to lose like 20, right? So let's see. All right, so it's gone. It's gone. It's gone. It's gone. It's gone. It's sort of gone. It's going in the negative direction. Oh my goodness. Look at that. We're so dead. We're so in the negative. That's a huge problem for us. We somehow have to restrict the containment from going negative. And that's something we need to do right here on this line. In order to restrict a value between a lower bound and an upper bound, a minimum and a maximum value, we can constrain that value. So the way we do this is we're going to take our value of containment and we're going to set it equal to the constrain function. The constrain function takes 3 pieces of information. The value that you want to constrain. So I'm going to constrain containment. And then the lower limit and the upper limit. The smallest possible value and the largest possible value. Our lowest possible value is 0. Our largest possible value is max containment. So now if we try to go below 0, the constrain function is going to hard cap it at 0. If we try to go above max containment, the constrain function will hard cap it at max containment. And then look what we're doing. Oh, look at that. We're spawning another cell. That's why those cells kept popping up. All right, so now let's check and see if we can go below 0. So I'm going to hit X to explode my cells. I'm exploding. All right, and I'm going to try to explode another one. Look at that. My containment will no longer go below 0. Constraining worked beautifully. I see mission 8 right here. Boy, do I want to go to it, but I know I just did mission 6. So that means mission 7's got to be living out there somewhere. So we should really take a look at it. Oh, right. Because right now we can remove containment, right? Let's see. Let me refresh my page. I can take containment damage, but I can't get any back. When I score a goal, I'm supposed to be able to give myself some of my containment back because I'm doing my job. I'm containing these reactor cells. So we got to look here. Where is it going to place us? It's inside of the check cell goal collisions function. And we already looked in here for a lot of our cell collisions. Here's our question that checks for our rectangular collisions between a cell and our goal. And if we do that, we increase our score by 1. But now we should add some containment to our score or give ourselves some containment back. And if you look right now, what are we giving back to ourselves? We're giving back 0 containment. That's not what we want. So we're going to change that. We're going to add back, I don't know, 5, 10, 15? Of course not. We have a constant variable that we defined at the start of this video called containment restore per save. I think it's set to 8. Now, here's the problem. Tell me what you think. What do you think the problem is going to be? Right now, if I score a goal, what's going to happen? Whoa, our containment has increased past the bar. Look at that. We've got way too much containment. Our containment is too high. In fact, if I blow up a cell, Our containment barely decreased because I had so much left over. We have gone past our maximum value. So you know what we have to do here. We have to constrain our containment value. So I'm going to type containment equals, and I'll call the constrain function. What do I want to constrain? It's the value of containment. The lower bound is 0, and this time the upper bound is what is important, and that is going to be our maximum containment. So now, if we score a goal right off the bat, we're not going to get more containment than our system has available to us. We're not going to go past max containment. Nope, didn't do it. Nope, didn't do it. Wonderful. Hey, I know Mission 8 lives out there. I've seen it. What we need to do is trigger a game over when containment is depleted. If I look, we'll get to Mission 8, but I'm just going to scroll down to my key pressed functions, because if you remember, we had a game over hotkey. It was G. That game over hotkey is no longer in here. We don't need that hotkey anymore because we now have an actual game over condition, and that is when our containment is less than or equal to 0. So we're going to check this. All right, when this happens, we want to trigger the game over. So what exactly does that mean? Well, if you remember, we have a variable called game, a current game mode, which is keeping track of the game state, whether it's, play, start, or lose. So we need to change that variable when it's game over. We're going to say current game mode equals our game mode variable, and we're going to access its lose property, play property, or start property. Well, if it's game over, we are dead. We're going to access its lose property, which will then force the game to draw the game over overlay and make us reset the game. All right, so let's test this out. Let's test this whole entire system. All right, so we're moving. Zoop. All right, so that looked good. I scored. I can take damage. Hotkey explosion. I can score some cells back. All right, everything's working good. Oh, that's a sound effect of me scoring. I like that sound effect. All right, push this one in, and then let's just blow up a bunch of cells. Well, let's make sure we're not going over. All right, I didn't go over. Nope. All right, so it's contained nicely here. And so now I'm going to blow up the cells, blow them up. All right, this next one might end me. Let's see. And it does. So if you look here, I have reactor failure. The game over screen was triggered correctly. Now, if I hit enter to restart, we should hopefully reset every variable, including our containment. So let's take a look. And look at that. My containment goes back to its starting value of 100. So this lesson, all 8 missions are complete. Nice job. Well done. This is a great extra system that we have built on top of our core gameplay mechanic. And right now, everything exists sort of static, right? If we think about it, we have these cells that exist in our game, but they're stable. We would love for them to be unstable. So as time moves on, they will begin to deteriorate and potentially explode. We also have our containment system that we are sort of triggering with a hotkey press. We don't want that to happen. We want our containment system to trigger every time one of these cells explodes. And so what this is going to force us to do is introduce timing into our game. And that's something that we'll look at in our next video. So I'll see you then.